Hey there, I am absolutely thrilled you're joining us for this explainer today. If you've ever wondered how to perfectly calculate your travel times, or if you just want to finally master the fundamental math of motion, you are exactly in the right place. Today, we're going to break down the science and mathematics of moving from point A to point B. We're stripping away all the confusion to look at the incredibly logical, beautiful relationships between speed, distance, and time. Okay, let's dive into this. Here's our roadmap for today. We'll hit the basics of speed, figure out calculating distance and time, unlock the magic of unit conversions, and finish up with a real-world travel math boss battle. But before we even touch a single formula, picture this. You wake up, look at the clock, and boom, you are running incredibly late for school or work. Now, you might have planned a nice casual stroll, but suddenly, you're sprinting out the door. Why? Well, because without even thinking about it, your brain already totally gets the physics of motion. You intuitively know that your speed dictates your time. And honestly, that perfectly illustrates the inverse relationship between speed and time. Slower speed equals more time. Faster speed equals less time. It's like a seesaw. The moment you bump up your speed and start running, the time it takes to get there shrinks. We literally experience this every single day, and it is the absolute perfect setup for the math we're about to do.
All right, part one, the basics of speed.
So what is speed exactly?
Simply put, it's the distance covered by a moving object in a given unit of time. And hey, notice I said a moving object. Standing perfectly still, drinking your morning coffee, yeah, that doesn't count. That is zero speed. But the second you start moving, we calculate your speed by taking the distance you've traveled and dividing it by the time it took. Speed equals distance divided by time. We're usually talking meters per second or kilometers per hour here.
Moving right along to part two, calculating distance and time. If you want to know exactly how far you've gone, you just take your speed and multiply it by time. Think about it like this. If you're cruising at a steady 10 kilometers per hour and you keep that pace up for 2 solid hours, you just multiply 10 by 2. Bam, 20 kilometers. The hours unit just neatly cancels out, leaving you purely with distance. Pretty elegant, right? And then there's time, which is probably our most precious resource. To figure that out, you just divide the distance by your speed. Say you've got a massive 200-kilometer road trip ahead, but oh no, you're stuck in awful traffic crawling at 20 kilometers per hour. Divide 200 by 20, and you instantly know you're stuck in that car for a grueling 10 hours. This little formula is a total lifesaver for planning your day. Section 3, Magic of Unit Conversions. Now, what's really interesting about this slide is the logic behind it, so we don't have to rely on rote memorization. Let's completely demystify this whole converting kilometers per hour to meters per second thing. Look, we know 1 kilometer is exactly 1,000 meters, right? And 1 hour, well, that's 60 minutes with 60 seconds each, giving us 3,600 seconds. If we set that up as a fraction, 1,000 over 3,600, and just simplify it down by crossing out zeros and dividing by 2, we get this absolute gem of a fraction, 5 over 18. Listen, 5 over 18 is your ultimate cheat code. Seriously, anytime you have a speed in kilometers per hour and you want it in meters per second, just multiply it by 5 over 18. Say you're going 36 kilometers per hour. Multiply 36 by 5 over 18. Well, 18 goes into 36 twice, and 2 times 5 is 10. Boom, you're moving at 10 meters per second. No massive calculator needed. And you gotta love the symmetry of math. If you ever need to go backwards and convert meters per second back to kilometers per hour, you literally just flip the cheat code upside down. Multiply your meters per second by 18 over 5. It is a total game changer once you see the logic behind the numbers. All right, section 4, real-world travel math. It's time to put these building blocks to the test. Okay, picture this. You're on a bus heading from Delhi to Agra. We've got two variables, a steady speed of 60 kilometers per hour and a travel time of 4 hours. Quick, before we solve it, can you calculate the total distance in your head? Let's walk through it and flex those problem-solving skills. Distance equals speed times time, so 60 times 4 gives us a 240-kilometer trip. But wait, what if the bus hits bad traffic and its speed drops by 20 kilometers per hour? Now we're only doing 40. To find our new time, we divide that 240-kilometer distance by our new 40 per hour speed, giving us 6 hours. So a trip that was supposed to be 4 hours is now 6. You just figured out that traffic jam cost you exactly 2 extra hours of your life. Let's step things up a bit with Rohit's run. Rohit is incredibly fast, blazing along at 75 kilometers per hour. He normally runs a 140-meter dash, But today, he wants to hit a target of 400 meters. Now, do you spot the trap here? His speed is in kilometers per hour, but the distance is in meters. Thankfully, we've got our trusty cheat code ready to go. First things first, we apply our 5/18 magic trick. 75 times 5/18 gives us roughly 20.83 meters per second. Much better. Next up, time. For his normal 140-meter distance, we divide 140 by 20.83, getting about 6.7 seconds. But for that big 400-meter goal, 400 divided by 20.83 equals 19.8 seconds. To find the extra time he needs, just subtract them. 19.8 minus 6.7 means Rohit needs exactly 13.1 extra seconds to crush his new goal. Step by step, it's just a giant puzzle that's super satisfying to solve. To wrap up our explainer today, I'm throwing a final boss battle challenge your way. If you cover 6 kilometers in 8 minutes, exactly how much extra speed do you need to cover that same distance in just 4 minutes? Remember that inverse relationship we talked about right at the beginning, and don't forget to convert those minutes to hours first. I highly encourage you to grab a piece of paper and work this one out. Thanks so much for hanging out with me to decode all of this today. Keep practicing those equations, stay curious, and I will catch you next time.